welcome back. We have a very interesting session actually today with Mr. Roberto Arbulu. He is the Vice President for SDS, and he have a very interesting, actually he is Senior Vice President at Strategic Project Solutions. He has over 20 years of experience in globally in delivering optimization, infrastructure, energy, and industrial capital projects. He is an author of technical publications focused on project production and optimization, control, and supply chains. For many years, Mr. Arbulu has been instructor both at Stanford University and Project Production Institute. The floor is yours, please.
Thank you, Mohammed. So, today, I'm not going to make a presentation. This is a masterclass. So we're going to learn a few things. Are you ready?
Yes.
Okay. And before we get into what we're going to do, help me distribute this session is about next project delivery practices. Okay? But obviously we can actually do a conference on project delivery practices, the next generation. Our intent is going to focus on few things that a lot of organizations around the world are paying a lot of attention. Okay, so we're going to simplify because we have only an hour and a few minutes. Now, before I describe what the objectives of this session are, we're going to do something a bit different. I want to ask you to read a case problem, which was being distributed. Right? We're going to give you 8 minutes to read it individually, right? And answer a couple of questions that are on the second page. Now, this case problem is a true story. The only thing we have done is we changed the name of the person in the story. Okay? So we're going to keep it really simple. If you have a pen, feel free to write down your answers to the questions. If you don't have a pen, don't worry about it. Just try to answer those questions in your head, and I will facilitate the discussion. I want to give you between 7 to 8 minutes to read the story. Go ahead, please. So, have you met someone like Omar? A lot of times? Somebody else? Okay. Have you met someone like Omar? Okay. So what is the problem that he has? Can you raise your hand so we can, if you want to talk, so.
I think he would like to stick to best practices. He would like to stick to best practices, and that's why he's deviating from the objective.
Okay.
And the objective is to deliver value at the end of the day. So he's deviating from that. Just for the sake of following best practices and best technologies and best processes and everything.
Okay, thank you so much. Is he in trouble?
Yes.
Right. Do you think he truly understands the problem he has?
No.
But is he's basically sitting down and doing nothing? No, right? He's trying a lot of things, right? What are the things that you remember from the story that he's trying to do? Just do a quick brainstorm. Yes, sir?
De-scope some of de-scope.
So he's de-scoping, right? Now, de-scoping is not always the right thing to do, right? It's not always something you can do, right? Because de-scoping has a significant impact on potential value from the customer perspective, right? Is it technically doable? Yes, it is, but it's not a good idea. But he's trying it, right? What else is he doing?
WBS, the advanced working and packaging. Yes.
Can you, yeah. I cannot hear you, sorry.
The advanced work packaging.
Yeah.
The packing, yes.
Yes. Packaging, advanced work packaging, yes. Yes, sir.
Using cost scheduling by hiring consultants.
Right. There's a focus on productivity, right?
Yeah.
So
Sorry.
he's actually tried to throw technology and resources without actually thinking things through. So he's gone for technology rather than, he's being technology focused than people focused.
Okay, good. Yes? You can speak louder without the microphone.
He hires a consultant to try to fix the problem.
Right. Okay. What else is he doing? Quickly. This is
Lean Six Sigma.
Lean Six Sigma, right? He's doing CPM, he's doing EVM, he's doing a bunch of things, right? So, is he talking to his team? Are you sure?
No information.
There's a little part of the story, right, where he's talking to different people, right? And so he's not basically working in his cave, right? Trying to, this is my problem. He opened it up, right? And so he asked members of his project team, some of them, not all of them, to say, hey, what can I do, right? So what are the unintended consequences, which is the first question. What are the unintended consequences of his decisions? Yes, sir?
No clear direction for the team.
No clear direction from the team? Yeah. Anybody else? Yes?
More time, more scope, more budget, more efforts, more resources.
Right. He's trying a lot of things, and he's not able to fix the problem. Okay? So, what would you recommend, given the amount of experience in the room, what would you recommend to Omar? I am Omar, right? What would you recommend to me? What should I do?
First, issues should be logged into the register. Issue register. Issue log.
An issue log?
Yes.
Okay.
I recommend to.
What should I do? I'm shaking. I need to go to my boss.
I recommend to change the way of thinking.
Yes.
Yeah, because changing the way of thinking may result in a new way of solution.
Okay, that's a good one. Here, please.
Engage your stakeholders and try to identify the root causes of all the problems.
Okay.
Be more strategic. When we say strategic, means doing kind of prioritization, work as proof of concept, run a pilot, find a minimal viable product, get the buy-in, at least make a couple of deliverables, make things happening so you can get the buy-in from the boss. Don't wait the last minute. Okay, and maybe working in agile, where you involve and engage your boss in each iteration. And this means even there will be changes at the beginning, it will be less costly from doing it at the end.
Thank you so much. There was, yes, sir.
And interview this team and try to get feedback on the actions taken and recommendations for the team as well. Interviews.
How often do you think this story repeats in the world of project delivery?
Many.
So this can happen to any of us, right? The reality is that in the world we live today, we see multiple practices, right? Organizations, project teams are actually adopting, and this is just probably a short list, right? Some of them are in the story, some of them are not in the story. CPM, PERT, workplace planning, tool time, bunch of contracting strategies. People are going for off-site fabrication, which Omar is also doing. Do you pick that from the story? Right? So he's saying, look, I'm going to create modules, I'm going to assemble modules off-site, right? So he's doing that modernization as well. Agile, Scrum, Sprint, spreadsheets, Last Planner, Lean, and the list goes on and on. Even, you know, WhatsApp and chat, right? You can probably add more to the list. Which one are we missing?
Maybe we already talked about communication.
Communication, yeah. So, yes.
I think what we're missing is the probably proper risk management practices in the beginning of the project.
Right.
Identifying these risks and having the proper mitigation plans can help in seeing these risks and acting accordingly. So yeah, and design changes is a common risk that happens in projects.
So, yep, stakeholder analysis. So we can probably increase this list quite significantly.
SWOT analysis.
SWOT analysis, yeah. But what is the point we're trying to make? why did we ask you to read this K problem to start with? The point we're trying to make is that we see a lot of organizations, it doesn't matter where we go, that are actually trying multiple things, but when you look at the project performance, it's not improving, right? But they're not like this, right? They're doing things. Companies keep trying to do things, but they're not improving performance, right? Like Walmart. Okay? And so the question is, why? What's going on? Should we continue doing that? What do you think that's happening?
Maybe a couple of things. The team cohesion is known, that's not the team cohesion to carry out the work. The other thing would be directions are not cascaded accordingly, so it is get lost along the way, so people get scattered all over the place doing things simultaneously.
Okay. You also had a comment, I think.
Yes. Sometimes we tend to do best practices as a check-the-box exercise.
Okay.
And without following up on the actions and the outcome of these best practices, if we not get and continue, there will be just a piece of paper.
Yeah.
Getting nothing.
Please.
We need a mindset change, I think. It's not about best practices anymore, it's about best bets for the organization. That really matches the organization maturity and appetite to change.
Right. Okay, good. There was a comment here. Sorry. Then we go with you, please.
I think so the key word here is adaptive. Adaptivity, which means like we are expecting the project is unique by itself, so it's have its own journey. Yes, it may get some failure from, certain points in the journey, but the point here, how you will be adaptive in fixing those things. What's the right tool to be selected to come up with the kind of mitigation, let's call it. So you need to be adaptive, and you may expect to be getting some falls here and there. So it's nothing rosy. You don't expect things goes, otherwise it's not called a project, it will be an operation.
Right. Well, thank you. Oh, sorry, one more. Excuse me.
Are we sure that we are delivering the right project or product for the client?
Yeah. A friend of mine one day told me, look, we need to make sure we're making the same movie. Right? If we're members of the same team, right? Are we making the same movie? Right? And that really struck me on sometimes when it happens, right? But look, let's keep exploring a bit more, because what we're going to do today is we're going to share with you what other companies are doing to close existing gaps, right? In addition to everything you have seen, right? What else are other companies doing? Right? What are they investing in? Okay? And how they're closing these gaps. Are you familiar with this curve of the ability to influence? Probably. Have you seen it before? Yes? No? Raise your hand who has not seen it. Okay. Now, this wasn't created last month. It was created in 1975. Okay? Some of you were probably not even born when this was created. And the idea here is that as we move through the construction phase, the ability to influence the outcome of the project goes down, right? If we can influence, or if we have the opportunity to move right here and make decisions in the engineering and design phase, we can significantly influence that outcome. That's what this says. However, right, that's theory. The practice tells us that when things go wrong, management intervention kicks in here, right? We start picking up the phone calls, right? Going desperate, problem is running late, we become Omar, right? Omar is on the top of that red line. He's sitting on the top, like this, right? And so that's one of the issues that we see, right? We are not, as an industry, investing, I would say, in the right things. We are investing, right? And sometimes we tend to focus a lot on innovation, but how do we make sure that the innovation is connected with improving the performance of our projects? right? We see a huge disconnection. So I wanted to bring to your attention a couple of pieces of information, one from 2013 and another one that was published last year. I do have a lot of friends in McKinsey, and they offer me to be able to present this to you, right? And what this is showing, if you look at put your attention on this one first. 2013, mega projects more than $1 billion, mining, oil and gas, and infrastructure, right? I know it's a lot of information here, but I want you to read what it says here. 98% of the projects incur cost overruns and delays. The average cost increase is 80% of original value. The average slippage is 20 months behind original schedule. If you ask me, we're not performing, right? And in 10 years, roughly, things have not changed. Look at this new analysis they have done, right? It's about, if you look at railways, right? 120% over budget. If you look at roads, almost 100, right? And 60% more schedule. Now, these are numbers at the global level, right? And they have about 427 projects. So this is not a sample data of 10 or 15. We're talking about a significant amount of projects around the world. So what is happening is connecting the stories. The Omar situation happens around the world and is resulting in things like this. Okay? So if you are the lucky 2%, you need to raise your hand because I want to have a conversation with you. Are you the lucky 2%? You're not. Well, sounds like we're not going to have a conversation. But let's have a different conversation of what other companies are doing. Is this making sense to you?
Yes.
Okay? This is public information, by the way, so I'm more happy to provide some links later on if you want to. So what are we going to do in this session? And I purposely did not start with this. Okay? We're going to focus on three things in the remaining time. One is to recognize the gap in the current approach and why this gap exists, what is happening to Omar. We're going to gain some awareness of fundamental production relationships applied to capital projects. One of the gaps that companies are trying to close is how we do work. And I know this sounds simple, right? How we do work. It's not about scheduling, just in case. I will expand on it, right? And so, and the last one is to gain a common understanding of how other companies around the world are approaching project delivery, what they're doing, right? And how they're benefiting. Those are the three objectives of this session, okay? We're going to follow through. We just did number one, did number two. I'm gonna move into this technical framework in a minute for about half an hour. And then we're gonna quickly go through some stories. Maybe we use more than 15 minutes. And we should be finishing, dedicate some time to some key takeaways and some class deltas, okay? If you have any comment or any question, you can raise your hand and we can have a conversation. As I said, this is not a presentation. I did not come here to present. I came here to talk with you, okay? So we're not gonna go to a Q&A at the end, no. If you will have a question, just let me know and I will handle the time, make sure that we finish on time. That make sense? Yes. Yeah. So let's start. In our industry, we are enamored, in love, with the schedules, right? There's nothing wrong about it, okay? I didn't come here to tell you, hey, let's stop doing the scheduling. No. The point is that the schedules are, or have become, a tool, in many cases, to do project accounting, right? Meaning to report and forecast project progress. Do we need that? Of course we need that, right? But what we are going to focus today is, although the schedule, we have it, and it's focusing on dates and progress, right? Again, nothing wrong with it. There is a production system, right? Physical, if we're doing assembly or installation, or in engineering, knowledge work. Have you heard the difference between knowledge and craft work? Are you familiar with those terminologies? Knowledge and craft work, right? I'm a knowledge worker. If you're an engineer, you're a knowledge worker, right? If you're a crew, you're a craft work, right? So that's basically the difference. But the point here is that a lot of organizations are focusing on how can they optimize the project production systems that they have, right? On how they produce. And when we focus on this side of the equation, we're going to talk about things like rates and throughput. We're not going to necessarily talk about dates. Not that dates are not important. Yes, they are, right? So the gap, one of the gaps in the industry, is that we have focused over the years significantly around the world. This is not only in KSA, we see this happening everywhere. Significantly on project administration, right? We do a lot of project administration, but we're missing, we believe, we're here proposing you, right, that we're missing elements on how teams actually do work. How can we expect to improve performance if we do not change how we do the work? I don't know about you, but to me it's like a little bit crazy, right? So the purpose of this schematic is to position that we're going to be talking about this part here, okay? So what does it mean? In any project, we have multiple different types of production systems. And we could have designers, fabrication, we could have transportation, right? Nothing new to you, I'm just positioning it, right? Until we have some installation, right? We could have also fabrication of parts and different things. And so the concept of a production system is that things will flow through, okay? That things will flow through the system, okay? So the time it takes for what just happened here to move through the system will be something known as a cycle time, okay? The cycle time for an engineering drawing or an engineering package to move through the system is something we can measure, correct? If we are doing fabrication of site, the cycle time of assembling something, we can measure, right? If we are looking to reduce a schedule, compress a schedule, like Omar wants, right? One of the things that we probably need to do is to start looking at, can we reduce the cycle time, right? And so in this class, we're going to concentrate on understanding this a little bit more. Are you with me so far? Okay. We're going to talk about things like cycle time, like throughput, like working process and other things that I'm going to obviously explain in a minute. So one of the questions is, how do we get systems, equipment, modules, packages, whatever you can think of, through the production system quicker?
Stronger supply chain.
The stronger?
Supply chain.
Yeah. The supply chain is an element of the production system for sure, right? So if you are an engineering company, and I didn't ask you who you are because otherwise we will need more time, but if your business is just engineering, do you think you have a production system engineering only? No. Yes, no? No? Right? It's an element of the whole system, but you do have an engineering production system, right? Do you produce any engineering deliverables and packages? Yes, you do, right? So each package, basically, as it moves through a system, it has a specific duration, right? If that duration takes longer, we're going to have some issues with the schedule, right? And so what a lot of companies are doing in this next generation of thinking, as some of you, the lady behind was saying, we need a new way of thinking. This is how they're thinking about it. Understanding things from a production perspective. Let me expand. In order to do this, we're going to do a quick quiz. So, we're going to ask you to do two things. In that schematic, right, let me put perhaps a different example. Let's say that I am a pile. I need to be driven into the ground. Construction example, right? Easy, right? I am a pile, right? So a lot of things are being done to me, the pile, right? First of all, I need to be driven into the ground, right? That means that I am driven into the ground. Then somebody is, let's say it's a precast pile, right? Someone has to cut the top of it, right? And then someone has to put a footing on top of it, right? So as a pile, me, I am actually traveling through the production system, hypothetically, not physically, obviously, right? But different things are being done to me, right? And the more time I take as a pile in the system, the longer what? The cycle time, right? And if we want to compress the schedules, we will need to find a way of compressing that cycle time. Okay? So, what we mean here is WIP, by the way, is not work in progress like in earned value management. Have you heard about work in progress?
Yes.
This is work in process. Work in process is measure a number of units. In my example will be how many piles are currently in the system. Got it? 1, 10, 100, right? That are being worked on. And so the question for you is, if we increase the amount of work in process, what do you think is going to happen with the cycle time? That's the first question we're going to ask you. Do you think it increases? Do you think this is going down? We'll show you some charts in a minute. The utilization. Utilization means any production system has a capacity, right? And the capacity is generated through the resources that we use. If we use those resources to the maximum possible, this is from 0 to 100, right? Let's say that we use our resources 100%. Do we believe, we us, that the cycle time is going to go down or is going to go up? If it go up, in what form? Okay, but hold on. We're going to answer these one by one. The first one we're going to do is the cycle time and utilization. So I ask you to pick up your phone. I hope you have one. Scan this code and pick one of these 6 options. If you don't know, which is option 6, that's okay.
Excuse me, can you just repeat the utilization part?
Yes, so the utilization is, in a production system, there's certain capacity. If that capacity is used at the maximum level, 100% of that capacity, what happens with the cycle time? Right? Anybody scan it? Because I need to move to the next slide. Got it? All right, so let's see what happens. Okay, these are your answers. This is anonymous, unless you want to put your name. Okay, so we have about 40 people in the room, and I can see only a handful of answers, so let's see. You can only pick one, by the way, not 2. Can we right-click and reload in case this didn't come up? There we go. 11. Okay. 13, 11. Okay. So, what does it tell you? Let's say that we are a project team. We work on the same project, right? Are we on the same page?
No.
I'm not. I didn't give you the answer. I will. But we're not on the same page, right? So, option 1. If we believe that is the option, that means that if I increase the utilization to 100%, I'm going to start moving faster. See the line? Right? This one, option 4, is exactly the opposite. Right? and we have also 11. Now 13, most of you, I would say more than 50%, are of the opinion that the more we use the capacity, the cycle time go up, right? Just a different shape, but it's the same concept, okay? So the first problem we have is that we're not on the same page. We will explore in a minute. Let's do another one. Can you click on it, please? So pick up your phones. Yep.
Next slide, please.
I think you got it stuck. I know you need the answer, and I'll give it to you in 5 minutes, but I know. All right. So let's do the same with this idea of, go back. Okay, here we go. So, working process, right? Do you think that if we put more in the system, right, increase the working process, we're going to move faster, slower? Well, pick one, right? Pick one. Got it? I need to move to the next one. Okay, people are still scanning. Got it? All right. Aha. So, same situation, right? We're not on the same page, right? If we are the same project team and we try to optimize work, this tells me that the same team will do it differently. Is this making sense to you?
Yes.
Right? In the same team, in the same company, potentially, right? This is more common than you think, okay? We have done this in other places, and we get something like this. We deal with flip charts. I just ask you for simplicity to scan the code, but these are two different groups, right? In two different places of the world. The situation is pretty similar. So you're not the only ones, right? This is graphically probably more like a noodle soup, right? Graphically more appealing. So, but let's explore what happens and what are the right answers in a minute. But we're going to do this by introducing a concept of what in these next project delivery practices, the way people are thinking about it, right? And we're going to do it through a very simple framework. We call it the 4 verbs, the 5 levers, and the 3 curves. In the 3 curves, you will find the answer to these 2 quizzes, okay? And so, why is it that we're talking about 4 verbs? So, if we're trying to improve the performance of any project, we need to focus on where the production happens, right? We tend to focus a lot on functional things, but if we don't focus on where the production happens, the likelihood that our project performance improve, I can tell you, is very low. Agree? That means engineering, transportation, fabrication. If you are making a decision to do modules, the small, medium-sized, simple, complex, it doesn't really matter. If you're doing something off-site, you're doing fabrication and assembly, same concept, right? How are we designing that production system that allow us to get certain throughput, right? And get cycle times down. That is the first idea. The second idea is the idea of 5 levers. From a production perspective, we have 5 things that we can play with, and these things are interconnected. So if you're looking to reduce costs and time and cash, right? For some of you, depends on who you are, your companies, cash might not be an issue, right? But if you're an owner, for instance, an owner-operator, meaning you're putting the money for your project, I guarantee you that cash is certainly a big deal, right? Even for contractors, right? Even for contractors, right? And so what is this telling us? Product design means the way we are actually engineering the asset. And there's nothing new about it, right? We can use different technologies, 3D models and things, which I'm not going to talk about. But if we say, for instance, that we're going to modularize the facility, a building, a plant, right, even a road, right, an airport, we're going to chunk it, right, now we're going to do some modules. That has huge implications on the design of the production process, and we should have actually put in here production, right? And that is not a schedule, by the way, in case you're asking, right? It's how we do the work, right? So if we make a decision in the engineering phase to change something in the asset, the question is, what are the implications to the actual production system that we're going to go through? Okay? In, let's say, traditional project management, from a traditional project management perspective, we focus quite a lot on things like this, okay? But as we move to the right, we're going to talk about capacity, inventory, and variability. Capacity, from a production perspective, right? From a production perspective, resources are actually broken into two types, okay? What are the typical resources that we have? Not that we're going to spend a lot of time on this, but labor and equipment, correct? Is space a resource? Is a space a resource? Yes, right? I can have all the equipment I can get, I can have all the labor I can get, but if I don't have access to the space, I lose capacity, right? Resources and capacity are not synonymous. They are not interchangeable terms, right? The capacity of a system, capacity is a rate, is units over time, right? A system has the capacity to produce 100 piles per week. That's the capacity of a system, right? Resources are the equipment, the labor, all the stuff that we use that give the capacity to the system, right? So, what this is saying is that from a production perspective, we break resources into, at a minimum, two types. One are the ones that contribute to the capacity. We call those capacity contributors, right? One. Two, the other resource is the inventory. And when we say inventory, we don't mean a stock of materials only, right? In production terminologies, stocks and inventory are not synonymous, right? Another element of inventory is the amount of work in process in the system. So one thing is to have a stock of materials, another one is to have an inventory of work. Make sense? Inventory of work, right? There's no system in this planet that can work with zero inventory of work because you don't have throughput, right? And so I'm not here to tell you that you should actually minimize the amount of work to almost zero because you don't get any throughput, right? And the last one is about variability. I'm going to expand on that in a minute, right? We don't live in a world where things are flat. Things are always changing, right? The construction industry, the engineering and construction industry, the project management world is characterized by having a lot of variability. Variability is a concept, right? A lot of variability. Now let's ask you a question about this in a minute. One thing I wanted to pinpoint here is that these levers are actually interconnected. If I make some change in the product design or the process design, that might change the amount of inventory that I need to have, or it might change the amount of capacity, or actually might be inducing some variability in the system, right? This is like a balloon. Have you tried to press a balloon on a children's party, right? The air is not going anywhere, right? Therefore, the balloon is deformed, right? With these levers, it's the same thing, right? It's like if you reduce one, right, the air is not going anywhere. There's a probability that, as a concept, as a framework, right, one of the other ones are going to suffer, right? But in order to experience this, or ask your question is, and this is about variability. Let's assume that we are the same team, right? And we are in a meeting this afternoon at 3 o'clock in the afternoon. And we're planning the work for tomorrow. Let's say we're doing construction, whatever project you can imagine, okay? And as a team, we're gonna plan 10 activities for tomorrow, easy, right? The question we have for you is, how many of those 10, once we are the next day, right, and we look at what happened, right, how many of those 10 do you think we can get done? Simple question, okay? So scan the code, right? And we gave you some ranges here. This is gonna get removed automatically. We gave you some ranges. So let's see what happens. Do you think it's 9 or 10? This is in a 24-hour period, okay? Not next week, not next month.
Tomorrow.
7 or 8, 5 or 6, 3 or 4, less than 2. Can you?
I feel we should put like an advance because advance of the evaluation is required.
Hold that thought because we're going to talk about it. I was waiting for that question, and so thank you. All right, can you help me refresh the screen on the back, please? Something happened with the numbers. You guys answered? Okay, so let's see what happens. Oops. Go back. All right. So we have 2030 about, we have 20, 30, 41, right? So about half of you roughly are saying that in a 24-hour period, right, we do, out of the 10, we typically accomplish 4 or less, right? Some of you are saying, well, it's between 5 and 8. Now, how many of those 10 tasks do you think we should get done?
All.
That's the easy question, right? But that wasn't the question. The question is, how do we typically get done? Well, guess what? We have measured this around multiple projects, more than 1,000 projects around the world. And the number is 54%. On a daily basis, okay? It means you take a coin, flip it, and that is your probability of getting the work done around the world, okay? This is a mix of oil and gas, civil infrastructure, hospitals, different things. Now, what does this tell you? What does this tell you? What's the point? So what? What's the problem? Can you raise your hand so we can hear you? Yes, sir.
The variables may affect what we expect for tomorrow.
Correct. Yep. What else? Yep. Yes, sir. At the end.
It's a challenge to complete the task for tomorrow, then how about a month or a year after?
Yep. So do you think...
You need to be realistic.
Do you think that in average, right? As an average, the number I gave you, there are higher numbers and lower numbers. No question, right? It is an average. But there's something that is happening to 5 of those 10 activities, right? In a 24-hour period, right? And so that's what we call variability, right? What is actually stopping, right, these 5 activities in this simple example from being executed as we planned it? We planned this, right? We didn't outsource these to, no, we did it, right? And so there's another problem, right? Which is, let's say that I am the person or the crew responsible for the work on Monday. He is responsible for the work on Tuesday, you are Wednesday, Thursday, and she's Friday, right? We're going to execute the work in sort of a linear sequence. If we execute the work based on the average, I'm a 54% reliable, this is going to create a ripple effect, right? And the Friday person, right, if you do the math, the probability is 54 elevated to the 5th power. That's the probability that she will get to what she needs to do on Friday. The probability is almost 0. Right? So how do you think we typically fix this in industry? How do you think people fix this? Because they are experiencing, I can say that. Right? How do you think people fix it?
We probably plan what we can achieve.
Can you speak louder?
We probably plan what we can achieve. So we analyze our capacity and we plan it accordingly.
Yes?
Maybe redistribute the tasks over more teams.
Which means we're going to increase resources,
Yeah.
potentially increase the capacity. Okay? But remember, this is a simple list of 10 things, right? So one of the things that we see a lot of organizations doing is they go for overtime. Okay? Because this ripple effect implies, right, that if I didn't do my work, he cannot do it. He's going to have to do it anyway, and he's going to start working overtime. Sometimes the overtime is not during the week, sometimes it's on a Saturday, whatever the day is of the week. Right? And we use different means to address that. But that doesn't mean that we're not solving the true root cause of the problem. Right? We are putting patches on it. Right? And then we complain because we say, hey, our cost is going up. Yeah, no wonder. Right? No wonder. Right? And so, remember 54% as the number we have measured. Right? But let's take a look at the curves. So there are multiple things here. We're going to start with this one in the middle. Right? This is one we asked you. The issue is that if utilization goes up, okay, our cycle time is going to go up very quickly. This is a very counterintuitive, right? Because in our industry, we have tried to focus quite a lot on improving labor productivity, right? It's still today. The concept of improving labor productivity comes from the 1910s, from a guy called Frederick Taylor, that wasn't in construction or in project management. The guy was in manufacturing, right? And one of his assistants, his name was Henry Gantt, and Henry Gantt invented the Gantt chart that we use these days. Right? More than 120 years ago. The Gantt chart was not invented in construction, in case you're wondering. We still use it today, right? But the point is that, let me give you an example of this of real life. So let's say that you're traveling from your office to your house at the end of the workday. You're driving your car, right? And if there's a lot of traffic on the highway, let's say it's a lot of traffic, and you have to stop, right? What is going to happen with the time to get home? Increase, right? In this analogy, which is a real life analogy, the capacity of the highway has reached 100%, right? You cannot move, you stopped, right? The consequence for you as a person traveling through the system is that your cycle time increases rapidly. You will take more time to get home. In production systems, it's exactly the same. Okay? But we tend to focus on putting people to work and work as much as they can. Right? There is a difference between increasing the productivity of one operation in engineering and construction versus increasing the productivity of the system. They're not the same. Okay? Increasing the productivity of multiple operations and adding them up is not equal to more productivity in a system. Are you with me? Okay? Remember that this class is about what a lot of our companies are thinking about, right? And what they are thinking about is how can they optimize their production systems as a means to get shorter cycle times and move faster, get more throughput, do more with the same amount of resources. The second one we looked at, which is here, is there are two charts here in one. So let's focus on the one working process and cycle time on this on this side. The more we increase the working process, the cycle time will increase rapidly. Okay? So one thing that I'm a civil engineer by education. I have been a project engineer, superintendent, project manager, like many of you. So I have been in the trenches, and when I was younger, I was a pretty good work front opener. I was crazy. I was opening work fronts all over the place, right? But I didn't know, I wasn't really an effective work front closer. Did that make sense? Right? And so in our industry, we like to start work, but we're not good at completing it. Right? Things get a lot of time to get completed. And the more they take a lot of time, the more work in process gets stuck in the system. Right? What this tells you is that effect, right? Now there's another chart here, which is the throughput and the working process. And the throughput is really measured as a rate, right? Units over time, right? Number of piles per day, number of piles per week, whatever my example, right? If we have in our system a lot of working process, it's gonna get to a point where the throughput is gonna be flat. You see that curve? Yeah. Right? There's no more coming out of the system. Okay? There's no more coming out of the system.
Capacity is maximum.
Maybe I cannot add capacity, right? The capacity is limited, correct. Right? I cannot get more out of the system. Okay? And so what a lot of companies are doing are incorporating, right, a more detailed understanding of something that is known as operations science. Okay? How systems behave so they can actually optimize it. Right? This is not about changing the schedule or rebaselining the schedule, because we do that all the time, aren't we? Right? It's about how we can actually optimize these production systems. I'm not going to go through that one now. My intention is not to go through a lot of these formulas, okay? But what I meant by operational science is that it's true science that organizations are actually incorporating on the way they optimize their production. One of them is known Little's Law, which tells you that if we increase the working process mathematically, if you're an engineer or an architect or a person with technical background, if we increase the working process, the cycle time go through the roof. If you want to optimize cycle time, we have multiple components in here, right? I can give you access to some readings, but I want to do a quick exercise to show an example of what this is. But in order to do this exercise, I need 3 volunteers. I'm not going to ask you questions, I just need you to come forward and trust me to do an exercise. We're going to do a simulation. Who can work with me? 1? Yep, come over please. Now, what this tells you is that if we try to minimize cycle time, we have multiple components. One of these components is called BT, which means batch time. Okay? And the exercise that we're going to do is we're going to simulate the impact on producing whatever you think you can produce on engineering drawings, packages, modules, areas of a site, right? What happens when we have excessive batching in our production processes, okay? Would you mind to put yourself like 3, 1 next to each other, please? Yeah, come this way. You here, you here, okay. So, we're gonna do this twice. I have here 5 pens, just try to make it simple. And what you're gonna do is, I'm gonna simulate it, okay? I want you to count. So you're gonna have 5 pens here on the right. You're gonna take 1, but you're not gonna pass it to the next person, right? Right? This is a production process, right? 3 steps. This could be 100, this could be 5, 1,000. So you're gonna say 1, 2, 3, 4, 5. They need to hear you. Okay? Without passing the pen. Without passing, okay? But you have to count either slow, fast. You can do 1, 2, 3, 4, 5. Okay. Pick your pace. Make sense? You can go slower, you can go much slower, whatever you guys want. Make sense? You're gonna do the same thing with each of these pens. And then once you finish the 5, you move them to the next step in the production process. Make sense? Okay. Oops. So, but we're gonna measure the time. So, take the whole thing, wait a minute. Give me 1 second. Ready? 1, 2, 3.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
You start. Keep going.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
46 seconds. Okay? The total time it took us to produce 5 piles, 5 engineering packages, 5 whatever, was 46 seconds. Got it? Now we're going to change something now. What you need to do is you have to maintain the same speed that you use. Don't change it. Don't go faster, don't go, maintain the same one. Okay? That's very important. Now the difference is that when you finish one, now you can pass it. You continue. Okay? You can continue. If he gets one, he will count, he passes it, and so forth. And let's see how much time it takes. Okay? 1, 2, 3.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
23 seconds.
Yes.
Wait. Let's stop here. Okay? Let's analyze what happened. Okay? What happened? Did I ask you to go faster on the second one?
No.
No. Can I touch your?
Yeah.
Okay. What was his productivity on the first one? What was his productivity on the first one?
Let me tell you my understanding.
Okay.
I was doing all my job, then once I finish,
Yes.
once I finish it, I give it all to to the person who is next to
Correct.
me as a package.
Right.
So take it all.
Uh-huh.
This is in the first case.
Yes.
Okay. In second case, the process was one line. So when I finish something, I give it to him, then I
Right.
start the process. The second work.
Yeah. Now let's stop with something very basic but important. Did we change the process in the second one?
Yes.
Really?
No, in the process, no.
1, 2, 3. Did I ask them to shuffle? Did I ask somebody, hey, come over, let's put a fourth person? No, I didn't. We did not touch the process. Do you see that? We did not make any modifications to the sequence. Okay?
Only we eliminated the need for the store.
Right? And so, why is it that in this simple exercise, we have not changed the process? Because we see in our industry a lot of emphasis on trying to do process re-engineering, optimizing processes. And we, the industry, we forget about other details like the one we're trying to illustrate here. How the work is flowing through the process depends. You follow me? Okay? So what we have done here, we have illustrated something that is known as batching. We changed the batching rules, right? And we were able to reduce the cycle time without asking them to move faster. We did not change the productivity, right, of any of them between the first one and the second one. We move faster without focusing on increasing productivity. If you don't see that, I can repeat it. You need to see that, otherwise you are not getting out of the room.
We label productivity instead of the system overall.
What we focus on is improving the productivity of the system. Why? Because, can I have the 5 pen? Because we produce the same amount in half the time. Right? Did we add more resources? No. Did we add more capacity? No. Right? What we did is we focus on something that is known as batching rules, which is the second component in this formula. Okay? Why is it that in the first one, the cycle time actually is longer?
He was waiting for the...
Right, so stay there for me. So he did 5 in the first one and put them in between, right? And he started taking 1, right, producing 1, but these other 4, did we touch them? They were waiting, correct? And so what happens is there's another factor here called Q time, QT, which is the more we release work in different batches, the more this work is going to wait, right? And the more the work waits, the longer the cycle time. Well, the second batch is basically releasing work differently. The word release is important, right? What we have changed here is we're releasing work differently. Now, we went from 5 to 1. I'm not saying that batches of 1 technically in our world is always possible. That's not what we're saying. I just wanted to illustrate the effect, right? And so we need, have a seat please, thank you very much. Okay? So basically the point I'm trying to make is that the idea of next project delivery practices is on understanding the nature of the work, right? It's not about doing more scheduling, right? Sometimes we believe that we are going to be able to accelerate our projects by having a more detailed schedule, and that doesn't necessarily happen. If we don't influence our production processes, we're not going to get the results. Are you with me? Yes, sir.
Yeah. So your assumption is each personnel we have the practice on, they have the similar time of finishing the job. If we like put in the middle guy, it might take like much time for validation or for viewing, and the first person, which is like the drawer, will draw the initial design, will take less time. Somebody will get stuck in the middle. That's because it is taking a longer time to process.
Correct.
Yeah, so your example is built on assuming that everyone have in the factory line, that everyone have a special task with similar time to do that. If we put it in the production line and we have certain tasks with certain variance of time, then we have a threshold.
Yes.
So how can we...
Okay, so first of all, they were not moving at the same speed.
Yeah.
Do we agree? Yeah. They were counting at different speeds. Yeah. So one of them was slower than the other 2, right? And so there's always a bottleneck in the system, right? When there's a bottleneck in the system, right? If you want to improve the system, you better focus on increasing the capacity of that bottleneck. You don't need to increase the capacity of the entire system, right? One of those ideas, right? The definition of bottleneck is which resource is the highest or has the highest capacity utilization, right? I'm working like crazy, right? I cannot keep up, right? A lot of work is coming to me, right? I'm not gonna add more resources on this team. I need to focus on me, right? And so the question is, what tools, what means do we typically have to identify these things in real production systems, right? Because this is going to happen, okay? And so what you see here is a graphical representation of what we call here a production system that moved from engineering to, or design, engineering, fabrication, assembly, is purposely a meta level 1, where you can see what happens in between, okay? And so what companies are doing, they're not only looking at the operations, the boxes, right? they're looking at what happens in between, right? We tend to focus on making sure that capacity doesn't wait for work. That is a very productivity type mentality, right? But what we believe is more important, right? And we have been able to demonstrate that is probably, I would say between 80 and 90% of the opportunities to reduce cycle times is making sure that the work doesn't wait for capacity. The opposite. This is very important, so let me repeat it, right? We tend to focus a lot on making sure that the capacity doesn't wait for work, right? But it's more important when work is waiting for the capacity. Okay? And so that's one of the key ideas here, okay? So what is the point we're trying to make? Variability and working process and stocks are really a blind spot or gap that significantly increase project cost and schedule duration. Right? It's okay, we know how to engineer, we know how to create a schedule, but how to manage inventory and variability, how to be able to model that, right? And understand the consequences is really one of the big blind spots that a lot of organizations are trying to close. This makes sense? This has nothing to do with governance, this has nothing to do with having a stakeholder map or a risk register, right? Or things like that. We need to keep doing all that. This is augmenting. What else are they doing? Going back to Omar, right? Where's Mohammed? How much time do we have? Where's Mohammed in the back? What time is it? Excuse me.
We have 5 minutes.
5 minutes, okay. So let me move faster on this, okay? So I want to show you few examples of other organizations that have been able to, by looking at work, right, what they have achieved, right? First of all, they can actually compress the schedules by around 30% and reduce cost of cash in many cases up to 50%, okay? Like what I just demonstrated here, okay? And so remember that we're going to focus on the right. And so what exactly are they doing? One is they're using technology to be able to model and optimize production systems. And they're also using technology to control and improve these production systems. Control and improve. Control is not quality control, so we're going to explain that in a minute. So this is an example in engineering, right? People are actually using computer tools to model, create a computer model of the production system, the production process in engineering, right? And simulate it using computers. This is an example that needed to produce about 1,700 engineering deliverables by a certain date, right? What you see here, I don't know, I can look at it. What you see here is that it's a very simple example, 6 designers and 3 engineers. That was the current capacity, and it's going to go beyond the target. By looking at the production system, they look at what is the actual optimal working process, right? They were working with about 160 deliverables at any given time in the system, right? What they should have been working on is half of that. So somebody decided to put more work in the system, basically jam it in, right? Put more work in the system, hoping that at the end of the system, basically right here, more is going to come out of it, right? That didn't happen. Okay. And so they reduced the WIP by 100% and increased the capacity for some resources about 30 to 50%. Okay, so one of the practices that you see out there is the ability to model using computers these production systems. This is not a representation of a schedule. I want to be really clear, right? The emphasis on the production side. This is another example on supply, right? This is a supply production system, basically supplying modules, right? A modular electrical room, or MER, for a facility with a bunch of stuff on it, right? And that, the number of modules actually, what they did is an analysis of what happens in that supply process with the capacity, right? So if they double the capacity, right, meaning they want more, not capacity, excuse me. If they double the demand, right, from whatever number to twice that number, where do they need to focus on increasing the capacity in the system? This is an owner, operator, right, that is doing this, looking at their supply chains, right, and understanding, right, what happens with the capacity of the system. Okay? And also, what this tells you is that if you look at every one of these red bars, right, every single one of these things that you see here is a one resource in the system. And the red ones are actually the bottlenecks, going back to this gentleman's question, right? The red ones are actually the bottlenecks, right? And so what they're doing is they're actually investing in some of those bottlenecks in order to increase the cycle time. This is another example of doing a road where they create a map of the production system for doing a section of that road with piles and everything. And they can understand what happens with different levels of variability, right? So they model if they are exposed to more variability in the system, like the example of the 10 activities, right? If they execute at 50% versus 100% or 90%, what are the implications of the utilization of that capacity, right? In terms of control and improve, when we say control, we don't mean project controls. We don't mean creating S-curves and things that we're already doing, right? You're probably doing that in your companies. Okay, what we mean control is really making sure that, excuse me, the teams are focusing on how they're gonna do the work. And in this case, an engineering example that finished about 14 days ahead of the schedule. They actually started late, which is the blue. The green is what they're supposed to do. And they finished about 14 by focusing on how they're actually going to sequence the work and how they're going to control it on a daily basis, on a weekly basis, right? And the effort was complementary to the use of the schedules. Is this making sense so far? I'm going really quick on this, but okay? They put an engine, right? They put an engine, which is a production engine here, that will make sure that the schedule is met, right? Scheduling, the target, the engine, what control the work.
So here controlling, they are more focusing and more on the process design or the entire cycle?
Well, depending on their focus, this is an engineering example, so they're focusing on looking at, let's say, milestones that are 2-3 months ahead of them, right? And they focus on that next wave of work that is coming to them. The more they move forward, they actually extend that view and they keep that engine running. If that makes sense, right?
Yeah, I'm saying here, at the cycle, you have the product design, then you have the process design,
right?
And then you have the whole weight of
They focus on the 5 years.
Okay.
Yes, because they're focusing on designing the product, they focus on the standard processes, they focus on variability, how they allocate capacity, and they make sure that they don't push more work into the system, right? Like the example I gave you, right? So control and many other things. Control is about making sure that how you actually execute the work, right? This is another example of construction and supply, and this is actually what's done in London. This is Terminal 5. We were involved in the construction. If you have actually passed through London previously, you go to Terminal 5. The construction of Terminal 5 back in 2005 used all these principles, right? This is a $8 billion US program in London. Use all these principles as part of actually BAA, which is the owner of the airport, was one of the pioneers in looking at closing the gaps because of what they needed to do. This is another example in Australia of a team that is building a desalination plant, another infrastructure project, a multi-billion project where they look at what is the sequence of the work, what is the production processes, these are not schedules, and they can look at how much variability they have in the production processes on a daily basis as they build it, right? This is like you being connected to the machine at the hospital. I say, blip, 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 right? But at the execution level, right? As an integrated team, okay? And so there's a session on Tuesday, which I will be talking personally about this idea of digital twins of project production systems. So you're welcome to attend that session where I'm going to spend about 15 minutes on this particular idea, right? And this is part of the next practices. So I want to put myself in the middle. What is going to happen in our industry is that we can connect digital models, not 3D models or things like that, digital models of our production systems, and we can link them with the actual execution, right? Have you thought about going to a plant of some sort, and the plant has an operating room, control room, right? With the screens and the whole thing. And they have, it's an oil and gas plant, let's say, they have sensors in the pipelines, right? And the sensors transmit data, and the people sitting in the control room, they can see what's going on with the plant, right? That is a digital room of the refinery or the processing plant, right? In operation. The concept is similar, but in projects, right? How can we do this? And so a lot of organizations are going to focus on that, are focusing on that. So look, what I would like to do, just to wrap it up, one more thing, is I want you to scan these, please, and type 1 or 2 words of things that took your attention out of this class, which is a quick one, by the way. Right? What took your attention? Right? Just type it in, and we will see the results popping up on the screen. Or key takeaway. What are you taking away with you? Well, I think we need to go and refresh. Maybe not, but let me do it. Conscious of time. Okay. Wait. There we go. Go here. All right, so let's take a closer look at this. Operation equations, TH, probably throughput, production systems, linking supply chain management with PMP, practical process, productivity, best use of best practices, integrated, insightful, quantifiable, new way of working, and CT, probably cycle time. Now, we could have spent obviously more time, but I hope that this was actually a good use of your time. Was this actually a good use of your time?
Yes.
Okay, so that's the only thing I wanted to check, that you guys got value in an hour or so. Okay, thank you so much.
Thank you very much.